We left off with this drawing of a galvanic or voltaic cell and showing you how you can separate the oxidation and reduction half reactions of a redox reaction, and that you can collect the voltage, the movement of electrons from one side of the half reaction to the other, and that we can, in the middle of that, collecting the electricity as it moves from one side to the other, we could there power a light bulb. I drew a really bad light bulb, or we could just simply connect a voltmeter and figure out how much electricity is passing through the voltmeter right here at any given time, how much electricity is moving through. And so what we're going to learn to do next is, number one, figure out how much voltage is passing from one half reaction to the other in a galvanic cell. And then number two, and this is the really exciting part, figure out what combination of oxidation and reduction do you need to get a specific amount of voltage. So all of this is in section 18.3, standard reduction potential. And before we figure out how to build these voltaic cells, galvanic cells, I need to do a couple of definitions. So first of all, we're going to be talking a lot about cell voltage, which we abbreviate in chemistry, we abbreviate it as E cell. So that's a capital E and then a subscript cell. Or sometimes we just abbreviate it capital E. And so a lot of times I will say E cell just because it's faster or sounds faster than saying cell voltage. E cell we will define as the difference in the electric potential between the cathode and the anode. And that definition is probably not going to make a ton of sense right now, but as we move through this 18.3, that definition is going to make sense. So for now, you just kind of sit on it, and when we see some examples, it'll make more sense to you. So we also have what we call the standard reduction potential. The standard reduction potential is the electric potential of a reduction half reaction. All of our half reactions are tabulated or measured in terms of being a reduction reaction. So even though we always have one reduction and one oxidation, just for the sake of simplicity, we only tabulate our data in terms of reductions. And I'll show you how that will end up working. This word standard is a word that you've seen before. So the word standard is referring to a specific set of conditions. The standard conditions are 25 degrees C, which is pretty close to room temperature, 1 molarity for any solutions that might exist, and if we have gases, 1 atmosphere for the pressure. So the reduction potentials are tabulated and accurate when the reduction is being conducted at 25 degrees C in 1 molar solution or with 1 atmosphere of gas. And we'll look at the reduction potentials. Then we also have one more definition. We have the standard hydrogen electrode. And the standard hydrogen electrode is sometimes abbreviated capital SHE. And the standard hydrogen electrode is basically our baseline for all of the standard reduction potentials. The standard reduction potential is a measurement scale, just like inches. And in order for the scale to be established, somebody had to come along and say, we're going to call this one particular reduction reaction 0. We're going to make it our baseline. And for whatever reason, historically, we chose the hydrogen reduction reaction as our 0. This specifically is 2 hydrogen ions in solution, and because it's standard, it's a 1 molar solution, so that's 1 molar, being reduced, so that means plus 2 electrons, and we're generating 1 molecule of hydrogen H2 gas, and because this is standard, that gas is at 1 atmosphere. And we say that for this particular half reaction, we define the voltage, the potential, as 0. So we're defining this as the cell voltage, E cell, 0 volts. Because this is a standard reaction, we can go ahead and put that superscript degrees symbol type thing. That is the same notation that we have used in a lot of situations. So you've seen that in a lot of places like delta S standard, delta H standard, delta G standard. That symbol is just reminding us that this is being measured or done under standard conditions. So the standard hydrogen electrode reduction reaction is 0 volts. And all the other half reactions are measured and compared against the standard hydrogen electrode. So in a way, it's kind of our baseline.